For like ever, the human brain has been this total mystery, right? A complete black box. But that's all starting to change. Thanks to this incredible field called neurotechnology, it feels like we're finally finding the key. I mean, really think about it. What if you could control your computer just by thinking? Or what if we could restore a sense, like hearing, for someone who's lost it? Or, get this, treat some of the most awful brain disorders right at the source. It sounds like something straight out of a movie, but it's not. This is the real deal. This is what neurotechnology promises. Okay, so to really get a handle on this amazing new frontier, we've got to start with the basics. Let's break it all down, starting with the most important question of all. What exactly is neurotechnology? Put simply, it's pretty much any piece of tech that helps us understand, monitor, or even influence the brain and the nervous system. And we're talking about a huge range of stuff here. From those big, fancy brain scanners you see in hospitals, all the way down to tiny, microscopic implants. And believe me, this field is exploding right now. You know, no matter how complicated it all sounds, almost every single neurotechnology boils down to just two basic things: reading and writing. It's either reading the signals your brain is already sending out, or it's writing new information back into your brain to make something happen. So, reading and writing to the brain. That's the name of the game. But how do you actually do that? Well, that's the big challenge, right? And to tackle it, scientists have come up with two totally different ways to connect with the brain. All right, path number one is what we call non-invasive. Think of those caps with all the wires you see in movies. That's an EEG. It's reading your brainwaves right from your scalp. Totally safe. But the analogy here is perfect. It's like you're standing outside a concert hall. You can hear the symphony, sure, but you can't pick out the individual violins or cellos. It's a bit fuzzy. Now, if you want that crystal clear, high-definition signal, you got to go inside. And that brings us to the second path, invasive. This means surgery, placing tiny electrodes right on or even in the brain. Yeah, it comes with risks, obviously, but the level of detail you get is just incredible, unmatched. So you've got these two main approaches, right? Invasive and non-invasive. And using those approaches, researchers have built up this amazing neurotech toolkit. And inside this toolkit, there are basically three main types of tools that are already out there changing people's lives. So what are they? Okay, the big three are neuromodulation, neuroprostheses, and brain-machine interfaces, which you'll probably hear called BMIs for short. Each one does something different, but they're all seriously powerful. First up, neuromodulation. If we're talking reading and writing, this one is mostly about writing to the brain. The best way to think about it is like a pacemaker, but for your brain. It sends these super targeted electrical pulses to kind of, regulate and fix circuits that have gone haywire. The most famous example, and it's an amazing one, is how it can calm the tremors for people with Parkinson's disease. I mean, it literally gives them back control of their own bodies. Okay, next on the list, neuroprostheses. These are incredible. They're basically artificial replacements for parts of our nervous system that aren't working right. The whole goal here is restoration. And you've probably heard of the most common one, the cochlear implant. It's a device that gets around the damaged parts of the ear and stimulates the hearing nerve directly. It has allowed so many people to hear again, or even for the very first time. And that brings us to the third tool, brain-machine interfaces, or BMIs. Now, these are all about reading our thoughts, our intentions. A BMI listens to your brain's signals, decodes the patterns, and turns them into commands for a machine. Think about what this means for someone who's paralyzed. They can control a computer cursor or move a robotic arm just by thinking about it. It's absolutely game-changing. So, I know a lot of this stuff still sounds like it's from the distant future, but these tools are already making a huge difference in medicine today. And what's really exciting, or maybe a little scary, depending on how you look at it, is that we're right on the edge of a big shift. This tech is starting to move out of the hospital and into our everyday lives. I mean, just look at what's already happening. We use MRIs to find tumors and see the damage from a stroke. There's something called transcranial magnetic stimulation, or TMS, that uses magnetic fields to help people with severe depression. You've got spinal cord stimulators that can literally block chronic pain signals before they even get to the brain. This isn't theoretical stuff. These are real, life-altering treatments being used as we speak. Okay, so the medical side is incredible, we get it. But here's the next big question, the one that affects all of us. What happens when this technology goes mainstream? What happens when it's not just for patients, but for you? We are talking about a future where you might be able to send a text just by thinking it. Or maybe you could learn a new language or how to play the piano faster by stimulating the exact right parts of your brain. Or what about getting a boost to your athletic performance with instant brain-to-body feedback? This is way beyond a new smartphone. This is, well, it's a whole new way of being human. So yeah, we're standing right on the edge of this wild, high-tech future. And the potential is just massive. But with great power comes, well, you know the rest. We have to be smart about this. We have to start asking some really, really big questions about what all this means. On one hand, the promise is incredible. We're talking about the chance to treat, or maybe even cure, some of the most devastating brain disorders out there. At the same time, we could unlock human abilities we've only ever dreamed of. It's this dual promise of healing and enhancement. But, and this is a big but, this technology forces us to face some really tough ethical questions. I mean, think about it. If your thoughts can be read, who owns that data? Your boss? A tech company? What about informed consent? And what if a device that's supposed to help you also changes your personality, the very core of who you are? These aren't just philosophical questions for a classroom anymore. They're becoming real-world problems we have to solve. You know, what we're really talking about here are the tools to edit the source code of our own minds. And as we start to rewrite the rules of what's possible for the human brain, the biggest question isn't just, what can we do? It's what should we do? As we start to push past our biological limits, who do we want to become?